Assalamu alaikum everyone. Welcome to our project presentation. Our project is about the automatic street light system. This presentation explored the design and implementation of an automatic street light system utilizing a 555 primer IC and LDR sensor. The system aims to provide energy efficient and cost effective lighting for public spaces. This presentation is presented by MD Mahid Hassan Rimon, Alam Sani, MD Mushfiqur Rahim, Fuad Hassan, and Saibon Kabir. Let's move on to the introductory part. Street light plays a crucial role in enhancing safety and ensuring a urban light environment. Traditional street lights are often inefficient, consuming energy even during daylight hours. This project explored the development of an automatic street light system that utilizes a light-dependent laser sensor to control LED lights. By detecting ambient light level, the LDR enables the system to inactive street light only when natural lights are low below the certain threshold, thereby optimizing energy usage and reducing expenses. Implementing such as authorized system not only conserve energy but also contribute to environmental sustainability by lowering carbon emission associated with electricity production. Let's move on the motivation part. First, we talk about the energy efficiency. By utilizing sensor adapting control, this system ensured that street lights operate only when necessary, significantly reducing energy consumption. For instance, integrating traffic flow based smart LED street light on can LED can lead to energy saving between 68% to 82% dependent on the seasonal daylight variation. Then cost saving. Reducing energy consumption translates into significant cost saving over time, making the system economically valuable for public spaces. And lastly, improve safety. This system ensures proper illumination only when required, enhancing safety and security during the night hours. While some other studies suggest that increased lighting may not always correlate with reduced crime rates, strategies and well-designed lighting can improve public safety perception. That's all about my part. My next teammate will discuss the next part. Thank you.
Assalamu alaikum everyone. Myself Fuad Hassan Sabbi. At first, I will like to thank my group mate MD Nahid Hassan Rimon. Allow to me to present my speech. So, I will be discussing problem statement of automatic street light system. Problem statement. Exciting street light system often rely on timers or manual control, which can lead to energy wastage and inconvenience. The need for an automatic and efficient streetlight system using readily available component is evident. Moving to the next slide. Objectives: design and builds. Develop a prototype streetlight system using a 555 timer IC, LDR sensor and LED lights. Functionality: implement the system ability to automatically turn the LED lights on at dark and off at dawn. Performance evaluation: assess the performance of the prototype system in terms of responsiveness, energy efficiency and reliability. Moving to the next slide. Application: 1. Urban street lights, rural areas, Public space, smart infrastructure. Moving to the next slide. Component use. 555 timer IC, LDR, 10K resistor, 3 LEDs, additional component power supply, connection wire and breadboard. That of all my sides. Thank you everyone.
So this is Vim Subramanian, my topic is application of automatic street light systems. It's applicable for automatically turns lights on during low ambient light condition. It reduces unnecessary energy consumption, making it an eco-friendly solution. Where electricity supply is consistent, can use solar power. We can use it high traffic roads, public parks, and parking lots. It helps integrated with IoT for real-time data adapting, lighting, and remote control. My next part is component use. Here we mainly four component use: 555 timer IC, LGR, 10K resistor, 3 LEDs, and additional component we use: power supply, connecting wires, and breadboards. I welcome to my next group member. Thank you, sir.
Hello everyone, hope you all are doing fine. I will be the host for this part where I will be explaining about the circuit diagram for this project. For better understanding, previously as my groupmate has already explained about which components we have used. So as you can see on the screen, there is an LDR which we can say is the heart of our project. Then we have used the 555 timer. We have organized the 555 timer in such a way that it can be used in monostable mode. So what is monostable mode? Monostable mode is also known as the one shot mode. The 555 timer operate as a one shot pulse generator. How it works: when a logic low is applied to the trigger pin, the output becomes logic high for a specific time period. The time period is determined by the values of the connected resistor. After the time period, the output returns back to the low and waits for the next trigger. Then coming to LDR, when an LDR, also the LDR is known as light dependent resistor. So LDR senses light, its resistance decreases, meaning the more light it receives, the lower its resistance becomes. Explanation is that an LDR works by allowing more current to flow through it when exposed to light, which translates to a lower resistance. In darkness, its resistance is high and little current can pass through. So there is a lot of light. The LDR has low resistance, which means the voltage divider gives a low output voltage. The the low output voltage turns off the transistor, which cuts off the current to the LED. When it's dark, the LDR has high resistance, which means the voltage divider has high output voltage. Then high output voltage turns on the transistor, which turns on the LED. So I hope you have understand the circuit diagram. So next part is methodology. So how our project works. So the methodology is that the LDR sensor is used to detect changes in ambient light levels. When the light intensity decreases, the LDR resistance increases. As I have already told you about the LDR, the 555 timer IC is configured in a monostable multi-vibrator mode, generating a square wave signal. The frequency of this signal is determined by the values of the resistor and the capacitor in the circuit. The output of the 555 timer controls the LED lights, turning them on when the LED resistance exceeds a predetermined threshold and turning them off when the resistance falls below the threshold. So that was our methodology. Then we have done the simulation. So we have used Proteus 8 software for our simulation. We have given input light intensity values. For output we have used LED lights on off states. So analysis is the timing, response and efficiency. So here is a picture of our simulation picture. So by seeing this, you can have a doubt that in the circuit diagram previous, you have we have shown 10 kilo ohm resistance, but here in simulation part we have used the 330 ohm. So for the explanation for this is that in the circuit diagram we have used 10 kilo ohm, but in the simulation part we have used this ohm resistance because the time delay of the lights becomes more delay when we use the 10 kilo ohm, but it reduces and matches our project for the 330 kilo ohm. So we have also given a simulation video in our presentation which will be helpful for you to see, I guess. So the next part, this is the picture of our project we have done, and that's all for this part. The next part will be explained by another groupmate of my group. So I hope I have able to give an explanation which will be helpful for your better understanding. Thank you.
Assalamu alaikum. I'm Simon Kabir Jihan. The what is our advantages of this project? So let's talk about it. So the automatic street light system has several key advantages. First one, energy efficiency. By turning off during the day, it minimizes energy consumption. Automation. The system operates without manual intervention, enhancing convenience. Cost effectiveness. Reduced energy uses translates to long-term cost savings. Sustainability: the system contributes to a greener environment by conserving energy. Thus, benefits make the system a suitable solution for modern and digital world. So that's it. Let's discuss the results and key observation of this project. First of all, functionality. The prototype system effectively controlled the LED lights based on ambient light levels. Efficiency. The system demonstrated significant energy savings compared to traditional street lights. And last one, reliability. The system exhibited reliable performance, consistently turning on at dusk and off at dawn. So basically, overall, the project achieved the intended functionality of automating streetlights to save energy and reduce human intervention. Let's talk about conclusion and future scope. In conclusion, our project provides an efficient and sustainable solution for automating streetlights. The system has several advantages such as energy conservation, cost reduction, and ease of operation. It can play a significant role in smart city initiatives and reducing electricity wastage. Looking ahead, there are many possibilities for enhancing the system, including integration with solar power. Adding solar panels can make the system entirely energy independent. Smart sensor using motion sensor to detect movement and turn on lights only when necessary. Remote monitoring enabling IoT-based control and monitoring for centralized management. Scale Scalability, expanding the system for highways, parks, and industrial areas. With these improvements, the system can further contribute to sustainable and smart architecture development. References. Finally, we acknowledge the resources and references that supported this project. Number one, books and articles on 555 timer IC and circuits and LDR sensor. Number two, research paper and journals on the energy efficiency streetlight automation. Number three, online tutorials. Number four, manufacturer datasheets for components used in the project such as LEDs, resistor, and sensor. These resources provided the foundation for understanding and implementing our project effectively. So this is our project and our slide presentation. Do you have any question? Ask any type of question. That's it. And also thank you everyone for joining with us. Assalamu alaikum.